Well, ladies and gentlemen, we'll now move into the second keynote address by Dr. Ron Black, President and CEO, Rambus Inc., on the topic, Bringing Design-Led Manufacturing to Life, a New Way to Think. Maybe the industry needs a new model. I'd like to introduce him to the audience. Joining Rambus in mid-2012 as President and CEO, Dr. Ron Black has fostered a more open and collaborative environment at Rambus. With over 20 years of experience managing businesses and running companies in global semiconductor and mobile markets, Ron brings an entrepreneurial spirit to Rambus and provides the overall vision and leadership necessary to drive future growth. Before joining Rambus, Ron was the Chief Executive Officer for MobiWire and Wavecon, a publicly traded French wireless solutions company. And Ron has also served as Executive Vice President of the Client Systems Group at Agri Systems and has held a number of senior executive roles at other companies, including Motorola and IBM Microelectronics. Ladies and gentlemen, it is indeed an honor and a privilege. Please extend a very warm welcome to Dr. Ron Black.
Thank you very much for that warm applause. It's a pleasure to be here again. When I was hearing that introduction, I thought, maybe a better name for this lecture is bringing market-led design to design-led manufacturing. Because while I think as a CEO I'm qualified to talk a little bit about marketing and a little bit about design, a little bit about manufacturing, the truth is, despite having a PhD in engineering, I haven't done real work in 20 years. So if it was really deep design or deep manufacturing, I guarantee you would not be impressed. When I did this talk a few years ago, I injected some controversy. And I did that on purpose, and I'm going to try to do that again. Now, I'm not doing it because I want to win an argument or even convince you of a point, but like when I was teaching at university, to get you to think or think a little bit more deeply about things. So I hope at the end of this that you find something a little bit different, a little bit compelling, and it makes you go home when you're driving or walking and think about different things like business models and how this industry, and you'll see it follows right from Ray's presentation, might need a new way to do things. I'm also going to try to make it, like my students ask me, a little bit of interesting, maybe even comical. And I'll tell you, it was really, really hard to make thermodynamics comical for a 20-year-old or interesting. So hopefully it'll be a little bit better on this. So let me start with the semiconductor industry revenue, because it started to slow the growth. When I started in 1990, right out of university, it was a growing industry. It had been a growing industry for about 40 years. And I thought it was going to grow forever. But if you look at the projections recently, it's kind of flattish. That's a big change. And in fact, I'm thinking that, for the first time in my life, that the semiconductor industry, other than the cyclicalities, is going to be a steady state a drag on GDP. That is going to be different. Now, the question is why? Right? We talk about IoT. Is IoT going to cause it to grow more quickly? It might, but it might not. And I want to spend a minute on this slide to walk you through something. I started using this slide in the early 1990s, and I've continued it. And what I felt as a student of business is that the industry has really been driven by a new phase, really a platform-driven phase, about every decade. And underpinning that is binary compatibility, architectures and interfaces, switching cost issues. But if you think through time, starting in the 60s, it was about mainframes. There's a lot of companies that did mainframes, but really IBM owned that space. And you see that in these different phases. In the 1970s, it was mini computers, and DEC was a really big company doing that. They no longer exist, but they had great mini computers. There was other workstations in the Unix, and then in the 80s, it was the PC. Started with IBM, but it really became component providers with Wintel that really ended up owning that space, switching costs because of ISVs connected to ISAs. So it was a little bit different, but it was a really interesting stop. Then was the internet, and you would have thought companies like Lucent, where I worked, or Alcatel or Nortel would have really been winning that, but it was Cisco, and betting on a different technology, Ethernet, TCP/IP. Then in the 90s, it was mobile, right? And that really was a standard around GSM, the European standard, even though the company I'd worked at, Motorola, with their TDMA, should have been able to win, but really it was the GSM standard and then the evolution of that became. And there was likes of Nokia went from nothing, not even in the industry, to a behemoth, and then it's really a shell of itself, and it's all about Apple and Samsung. I submit to you that at the end of that phase, and these things aren't dead, they're just the phase, that something different happened. In the 2010 phrase, we started to see mass commoditization, especially of hardware. We saw the cloud, and we saw value shift from platforms to the data. And the companies that became behemoths at that time, really Google, Facebook, Amazon, were fundamentally different than the platform-based companies before. The monetization was around the data, and that's one of the points that Ray had made. So the question is on IoT, right? If that's the next big thing, if it is the value in a platform or in the data? You don't need binary compatibility to make sensors in a vineyard to having a mobile phone. So I'm not sure. My intuition, it's in the data. It's not in the platform. The other part, we talk about billions or tens of billions, or we heard on Ray's chart, 1 trillion things. 1 trillion things can't cost $100 a piece. They have to cost a very, very small amount. So if you're having a lot of volume, but the ASPs are declining at the same time, it's going to be hard to have that revenue click up if you're a semiconductor company. Now, the good news, and you heard it from Ray's presentation, and I'll say it here again, is the data can be extremely valuable. The problem we as a technology industry, and especially companies like mine, we make things like ARM does, but on memory and security. So we're an ingredient of an ingredient, and often of an ingredient to an ingredient. So the people that make the money off the data, we don't even know who they are or what they do in most cases. So how do we connect that as our ASPs are declining? Right. So let me shift a little bit to technology, because that's another reason why things are getting a bit more challenging. For many, many decades, Moore's law and Dennard scaling fueled performance and efficiency gains. Well, I think most people believe that the Dennard scaling stopped around 2005, and most people talk about Moore's law slowing. Now, near term, I think most people believe that Moore's law still has some advancements, but long term, we might have to rethink things. Right? At the very least, I think we're nearing the end, the economic end of Moore's law, so something has to change. So now, when you take all of those things and you put them together, something is changing, at least in the semiconductor technology space that I participate in. And the thing that's changed really a lot over the last 2 years is massive consolidation. There's about $202 billion of consolidation. I think 140 or 150 billion of it just last year, which was up from something like 15 or 16 million, whatever the numbers work out to be. So this consolidation has been global, and it's a thing that you gotta be bigger to be able to survive or make money. Now, consolidation, right, is the antithesis of the startup culture, but it is a mature and natural response to a maturing industry. And the reason for that is by putting companies together and cutting costs and expense. They talk about it as synergies, but let's be honest, it's cutting. You actually get earnings per share growth, right? Companies like Broadcom, right, or like Qualcomm, now which is acquiring NXP, which was in the process of acquiring Freescale. So think about a little fish getting eaten by a bigger fish, getting eaten by a bigger fish, all at the same time. It drives earning per share growth and tremendous value to shareholders. The question is, how do we actually drive continuous earnings per share growth when consolidation eventually ends? So think about that. We're not connected to the data so much. It's hard to get connected to the data. Growth in the industry is slowing. Technology is slowing. The industry is consolidating. Short term, it's good, but what's the long term? I submit to you that the industry is probably at a crossroads. It doesn't mean it's going to go away. It doesn't mean that it'll go continually. But it is at a crossroads, and I think people who think about things differently may be able to find the breakthrough. And we actually thought about this very deeply, and we decided to partner, Rambus, my company, with the Global Semiconductor Association, the GSA, to talk about the unparalleled consolidation, to talk about the changed business model, to talk about possibly a need for a new paradigm. And we actually did something. You could think of this as like a long economist article. It's written objectively. It's not written by us. It's written by somebody independent. We had to interview a lot of executives. And you can go to our website and you can download this. And there's a couple of really interesting things in here. One thing we're talking about is embracing open source, even for hardware. This morning we heard about ARM being acquired by SoftBank for, I think it was $33 billion, and they don't do any silicon, they make a design. Well, in 2010, a team at Berkeley created a new platform, RISC-V, not RISC and R-I-S-K, but RISC and RISC, Reduced Instruction Set Computing 5, which a Roman numeral 5. Guess what? It's open source. The ISA is for free. If that free ISA was adopted by ARM, right, it'd be very difficult to value them at $33 billion, wouldn't it? If their revenue magically went to zero. I'm not saying it is. They have a tremendous value, a huge ecosystem. There's binary compatibility. But that's an interesting thing. What happens if in IoT you adopted an open source hardware platform? The cost would be lower. We need to have lower costs. The barriers to entry when you're making an ingredient would be lower. That's interesting. One of the things that we think is interesting, and we'll show it later on, is programming chips in the field. So think about it as device configuration that you could do at any time, even when it's in the field. And maybe you can get paid for that. We'll talk about that. And that's the new monetization values. So if you want to get this, it's actually a pretty good read. It's a little bit academic, but it's kind of interesting. So where do we think it's going? We definitely think, and that takes right from Ray's presentation, it's all about the cloud and data for the obvious reasons. We think that there's still innovation in a lot of areas, a lot in new technologies, lots in new architectures and new approaches. Some of the things that we're doing, and we talk about this as an industry, not our specific things, but areas that are interesting to us, is new memory hierarchies, like with storage class memory, where you have the speed closer to a DRAM, but the persistence like flash, right? Intel announced 3D XPoint. It'll be more of a future. But it's a very interesting technology when it comes to play. We think that the backplane technology and the serial links and silicon photonics is going to be a very interesting play in the future. We think field programmable gate arrays in flexible architectures in the data center, like Microsoft's doing and Amazon's doing. So you're basically taking compute, bringing it closer to the data as opposed to bringing the data to the compute, is a very interesting area. And we definitely think that better security at the endpoints are interesting. And the reason for that is that security is an enormous problem. These are the largest breaches. I went to the website. This is actually outdated because I looked at Yahoo. It says, all right, 500 billion. It's actually bigger than that. 500 million, it's a billion. These are records that have been stolen, right, through time at a variety of them. It's a very interesting website if you go to this. It's scary. It's frighteningly scary, especially if these breaches have occurred, like we heard with Yahoo, over the course of years and they didn't know it? Wow. So we think that the endpoints connected to the data centers need to be secured. We think that the security is moving from an afterthought, look, how do I patch this? Like, maybe I need to design this in, and maybe I need to design it in right when I'm going through manufacturing. So one of the questions that I get all the time, because we have a security business, is, well, Ron, how can I know that this DRAM chip that I made is really the one that I made? My end customer asked me, I put this in my data center. What happens if somebody took off one of your chips, DRAMs are a standard, and put on another chip that had something in it that it's not supposed to be? I said, well, that's called device attestation. You can attest that you know that's yours because, in this case, a little commercial, if you use our technology, we can put a hardware root of trust in it. We provision it during manufacturing, and there's a database. So we can cycle every time that machine boots up, and we can say every one of those devices are yours, and this is when it was made. You can tie it to all sorts of different parameters. So that's an interesting way, and you're going to see that theme. Maybe that's a way to monetize something and get us closer to the data. So let me talk about exactly that. A couple of years ago, a customer partner of ours came to us and said, well, we don't want to configure our chips anymore using fuses. We want to do it in a different way. And we came up with a pretty cool way to do it, which is to use cryptographic keys. So we have a little core, a little hardware root of trust. You can think of it as like a tiny microprocessor, or somebody call it a mini secure element. You put it in every one of your devices. During the manufacturing process, during test, and it could be at wafer or final test, we inject the key. That key is stored in a database. It's a secret key, right? Only you have it, so there's no way to do it. And we can actually run the entire system out of your ERP system because we plumb into it using enterprise-class software. So we put all of these appliances on the testers in Asia where you do your manufacturing. This company happens to be in California. You run it, right, pull it out your ERP system, and you put it out there. So that is a really cool thing because you can actually configure the chip. You can add another GPU. You could take a GPU off. You can turn on a new I/O block. You could turn it off. You could do that right at the end of the factory. You could do it with the customer, say a handset customer, right? Or you could do it in the field. So you can turn on this functionality whenever you want. So if you can turn on something whenever you want, you can actually get close to the data and the service provider who owns the data to turn it on. So that can allow you to have a completely different monetization model. So today we provide these cores, right, for a price. We sell the infrastructure, we sell the enterprise class software. And strangely enough, as a former hardware company, our fastest growing space is in enterprise class software in driving these things, because in some models we just sell the entire system, but some we actually provision the devices and get paid for provisioning. I could imagine a time, right, like RISC-V, where we provide our security cores for free. They're for free. And we actually get paid not from our traditional customer, but from the service provider who turns on the device or configures it. So we connect not to the poor guy who's making the chip and has a slowing business, but to the service provider who has the data. And guess what? We can share part of that revenue, which could be much higher and much more interesting, with the chip guy. Think about that. You could even sell the chip at cost, reduce the actual cost of inventory by a huge amount, right? Probably $1 trillion saved in inventory. You can dynamically program it so you can actually have less excess and obsolescence because you can change the configuration no matter where you want to go. And you can actually make money at the end of the value chain where the data is, not in just making a widget. one of the areas when you bring together security in this application that we've had a lot of traction with recently is securing IoT endpoints. And what's interesting, so this just shows how we do it. We take a little core, you put it in a secure client, it goes in the customer's chip or his subsystem, and we have a cloud service where we can actually provision the keys. And what's interesting about this is, yeah, the security stuff is great, very much got to have this. We don't want to hack into the car or to the other expensive machine. But, right, and here's the interesting but, what's even more interesting to the service providers is to be able to use this little root key and the ubiquitous connectivity and the database that says, I know what that chip is and what it was bought and who it was sold to and why they sold it, to automatically load the firmware or the environment and actually provision the service. So instead of actually selling a box or a little thing, you go out, the box has to have somebody who goes there and he provisions it with the long keys and downloads stuff, all of that IT infrastructure. You just do it auto-magically over the air in a secure way. So that experience, it's more about the ease of use than it is about the security. It's very interesting. And if you think about what we do here and the new models and this, last year we provisioned over 1 billion devices. Some of it is device configuration, some of it is just loading secret keys, but over 1 billion. So it's not an insignificant amount. So let me try to bring this together. Does the industry need a new model? Well, if an industry is not growing, it's probably eventually declining. So if there's a great way to sell an IoT device for a tiny fractions of a penny and the volume really justifies it and it makes sense we go back to growth, no, I don't think we need it. It's worked in the last 40 years, it's great. But what happens if it doesn't? And think about Google. Think about Google's former competitors in search that attempted to charge for search. They didn't last. Google doesn't charge for search. They charge for the people who have the money because they want to sell something a little bit different. And I don't mind them pushing, says Ron likes blue suits, Ron happens to be in Bangalore, maybe Ron wants to buy a suit in Bangalore, so it pops up when I'm Googling something, right, or doing a search, and it's pushing me something. I'm okay with that, right? Don't exactly want my privacy and stuff, but if all they're doing is pushing blue suits in Bangalore, I don't think that's a really big problem for me. Now, I think there's a model here where we shouldn't charge for the chips, or we just charge them at cost, and then actually charge for much more valuable things like activating a device, right? Device attestation. I know absolutely that is the one that I did, not something else. Provisioning a service, making it a great user experience, because the value is in the data, right? And what's even better about this, right? When you sell a chip, you've sold it. But you can constantly provision things in the field forever. So the model is not just sell it once. Maybe the model is provision it multiple times in its useful lifetime. So let me leave you with one of my favorite quotes. It was by General George S. Patton. He's an unorthodox general in the Second World War. Actually, he fought in the First World War as well. He said, if everyone is thinking alike, then somebody isn't thinking. So I hope we're not all thinking alike. I hope maybe this has gotten you to think about the industry and things to do something different. I really, in my heart, do not believe IoT is a platform play. I don't think there's binary compatibility. I think it's a set of verticals that are all going to have different things. I think that free ISAs like RISC-V are going to become compelling. I think that business models that worked before are not going to work. I think we're ripe for rapid, right, disruption. And it doesn't mean that there won't be new winners and new companies that are technology and they're huge, but it'll probably also mean that there's a few companies that are losers. The dinosaurs shouldn't wait until the asteroid is screaming toward the Earth to think about things differently. So with that, I'll close it. Thank you very much for listening to me again.
Thank you very much indeed, Dr. Ron Black. Ladies and gentlemen, we have a couple of minutes for any questions that you might have. If you can please put your hands up, we'll have the mic reach you.
Ron, good morning. Thanks for the insightful lecture. This is Niranjan from Seagate, and I'm also part of ISA, Executive Council. I have a question. There were several models in which we have seen, you cited example of Google, that they do not charge for searches, but they get their revenue model from something else. A similar thing tried on IP. We pay for royalty for every IP that we use in our hardware. There were some attempts done by, I believe, our EDA industry collaborators where they try to sell EDA licenses per chip, but that did not work out. So with those examples in mind, where there are some successes and there are some not successes, why this would work? And why somebody would want to, because the mentality is that I got the hardware, I'm done. I don't want to pay further.
Yeah, it's a really good question. One of the things, again, as a student of business, when I see things that don't always work and take a long time to work, is because the person who specifies architecturally, the person who defines the pricing, the person who gets the benefit are spread out. They're not the same person. And so what we're trying to do here is connect the guy who gets the benefit and also has the money. So if you can get the guy who's at the service, and the service is where the money is, then it makes a lot of sense. I'll give you a hypothetical. This is not at all what we're doing yet, but it's the things that we aspire to do. If you have a 10-cent IoT device that you want to have a little secure core in and provision it, right, to put a secret key in to do something, you can't charge $1 for the 10-cent thing, right? The semiconductor company can't afford that cost structure. But what happens if that is an IoT device that goes to a great service, like that has a security element in it for digital rights management, so you're going to download very expensive content, making up a company like Netflix. So they're charging you for 8K content, $30 to buy a movie, and they know that they're getting that $7.99 a month. So you are worth thousands of dollars to them, right, or tens of thousands of dollars. To give you $1 to make sure that DRM download is really secure and it's not hijacked or counterfeit or sent out on the web is invaluable. So the semiconductor company, right, isn't where the money is. It's in the service. So I think a lot of times where you have conflict, where it doesn't really work, is when the two don't make sense. I'll give you an example that I was right on the board of a company that was doing this and ultimately chose not to. NFC technology. NFC technology is fantastic, right? I love it, right? I use Apple Pay all the time, right? Samsung Pay, Android Pay. I think it's really cool. It's tap and go. But that took over a decade, and I really think it was not until Apple just decided, because they own the ecosystem, they own the customer experience, that they could drive the ecosystem to drive it, that it actually made sense. Why? Because an NFC chip, right, the RF and the baseband part of it that puts together a little secure element, it's like $3, right? And you got to have all of the handsets having it, right? So that's like 2 billion per year, 1.6 billion. So somebody has to come up with that $4 billion, right? And are they going to sell more handsets? Well, no, they're not going to sell more handsets. And then you have to go to 10 to the 8th, right, merchants, somewhere around 10 to the 8th. You got to tell them, well, all of these, right, point of sale devices that you paid $350 from Ingenico or somebody from, you got to add another $3. So now we have, right, 10 of them per store times 10 to the 8th, right? It's just this enormous infrastructure. So until it actually gets going, it doesn't work. Why? Because I like the experience. But if you ask me to fund $15 billion so I can pay faster at the Whole Foods grocery market, it's not going to happen. So every time in the value chain, if you have multiple steps and the guy who pays is not the guy who benefits, it never works. or it always takes a really long time because you have to have somebody who owns an ecosystem that cares about that user experience, that actually puts it together and makes it work. Thank you, it's a great question. Am I done?
We'll just take one last question, if there is one. The gentleman in the front here.
Thank you for your very interesting talk, and I think it makes sense. My name is Vivek Sharma from ST Microelectronics. Now I can see that, and I think we all agree that there is going to be change definitively, whether it's completely disruptive or not. So my question is that during the transition, we have a set of customers today who will also undergo change. Do you see that there would be a period where we would be probably competing with our own customers? You know, we are silicon guys. There is a cloud here, multiple layers in between. So when we start moving closer towards the service guys, which many times our customers are doing that. So do you see that there is a potential risk of this business model?
It's another excellent question. I think it's more than the risk. I think it's happening, but I think it's happening in a different way, right? Apple does an enormous amount of silicon. They're competing with you. So there's a question about really where you add value and where you don't, and how you have to work with the ecosystem to do it. So our company used to just license IP. That's all we did. A customer comes to us and says, we want you to do a buffer chip. A buffer chip goes onto the high-end DIMM modules. And I told my team when we did some transformation in the company when I started 5 years ago, you must listen to the customer, right? And you must, right, adopt the unit of commerce to what he wants to buy. So normally, we would be licensing the IP to companies who make the chips. In this case, the customer went around his existing supplier and said, we really want you to come in and doing that. And we did it, and we also bought one of the companies that did it just last year and put them together. So I think this co-opetition, it's very natural. I think if you're honest about what you're really good at, and if there's some level of engagement, you can change the unit of commerce. And by the way, if you don't, you may find that the customers are doing that, because it's not just vertical integration, it's backwards integration. Another example, real world, of what we do. And this is public information, so I can say it. So Microsoft, we work with Microsoft. We announced a program with them on cryogenic computing. So here's Microsoft, just a software company, right? They're building cryogenic computers, hardware. We're doing the memory subsystem design, because it's a lot of very interesting technology. This is one of the disruptive factors. So at 77 Kelvin or 4 Kelvin or 2.5 millikelvin in helium-3, helium-4, that type of structure, it used to, when I was in school looking at this type of technology, it cost you more to cool it, right, than the benefit that you go when you had superconductive chips, because the transistor budgets weren't big enough. That crossover point is now gone. Doesn't mean there's not a technology challenges, but there's a software company that's looking at being a hardware company to make their data centers even bigger to compete with their competitors like AWS. So I think it's inevitable, and that's where you're going to have things that'll be completely different. People who were competitors before might be partners, and people who were customers might be competitors. This is an excellent question.
Thank you very much. On that note, I'd like to thank Dr. Ron Black. I'd like to request Anita Bidappa, Director Enterprise Systems Development, IBM, to present a small token of our appreciation to Dr. Ron Black. Ladies and gentlemen, please give him a big round of applause for that very informative and enlightening keynote. We'd like to take this time once again to thank Dr. Ron Black for having accepted our invitation and for being our keynote speaker this afternoon.